This is a quick recap video of chapter Motion in a Straight Line. Mechanics. It is the branch of physics that deals with the condition of rest or motion of the material objects around us. Statics. It is a branch of mechanics that deals with the study of objects at rest or in equilibrium. Kinematics. It is a branch of mechanics that deals with the study of motion of objects without considering the cause of motion. Dynamics. It is the branch of mechanics that deals with the study of motion of objects taking into consideration the cause of their motion. Now, rest. An object is at rest if it does not change its position with respect to its surroundings with the passage of time. Motion. An object is in motion if it changes its position with respect to its surroundings with the passage of time. Now, rest and motion are relative terms. No body can exist in a state of absolute rest or of absolute motion. Point object. If the position of an object changes by a distance much greater than its own size in a reasonable duration of time, then the object may be regarded as a point object. Now, one-dimensional motion. The motion of an object is said to be one-dimensional motion if only one out of the three coordinates specifying the position of the object changes with time. In such a motion, an object moves along a straight line path. Two-dimensional motion. The motion of an object is said to be two-dimensional motion if two out of the three coordinates specifying the position of the object changes with the passage of time. In such a motion, the object moves in a plane. Three-dimensional motion. The motion of an object is said to be three-dimensional motion if all the three coordinates specifying the position of the object change with time. In such a motion, the object moves in space. Now, distance or path length. It is the length of the actual path traversed by a body between its initial and final position. It is a scalar quantity. Its SI unit is a meter. It is always positive or zero. Now, displacement. It is defined as the change in the position of an object in a fixed direction. It is given by a vector drawn from the initial position to the final position of the object. It is a vector quantity. It can be positive, negative, or zero. Its SI unit is meter. The magnitude of the displacement is less than or equal to the actual distance traveled by the object in the given time interval. Now, speed. It is the rate of change of position of a body in any direction. Speed, which is equals to distance traveled upon time taken. Now, speed is of four types. First is uniform speed, variable speed, average speed, and instantaneous speed. Uniform speed. An object is said to be moving with a uniform speed if it covers equal distance in equal intervals of time, however small these time intervals may be. Variable speed. An object is said to be moving with a variable speed if it covers unequal distance in equal intervals of time. Average speed. It is equal to the total distance traveled by the object divided by the total time taken to cover the distance. So, and last one is instantaneous speed. The speed of an object at any particular instant or of the time or at a particular point of its path is called instantaneous speed of the object. Instantaneous speed v, which is equals to limit t tends to 0 del x upon del t, which is equals to dx upon dt. And now, velocity. It is the rate of change of position of an object in a particular direction. It is equal to the displacement covered by a body per unit time. So velocity will be equals to displacement upon time. Velocity is a vector quantity. Its SI unit is meter per second and dimensional formula is m0l1 t minus 1. Now it is also four types: uniform, variable, average, and instantaneous. Uniform. A uniform velocity. A body is said to be moving with a uniform velocity if it covers equal displacements in equal intervals of time. However small these time intervals may be. Now, variable velocity. A body is said to be moving with variable velocity if either its speed changes or direction of motion changes or both change with time. Average velocity. It is equal to the net displacement covered divided by the total time taken. So average velocity will be equals to net displacement upon total time taken, which we can write that V average is equals to x2 minus x1 upon t2 minus t1, which is equals to del x upon del t. And last is instantaneous velocity. The velocity of an object at a particular instant of time or a particular point of its path is called the instantaneous velocity, which will be equals to tx upon dt. Now let's understand uniform motion. An object is said to be in a uniform motion if it covers equal distance in equal intervals of time, however small these intervals may be, in the same fixed direction. Now, displacement in uniform motion. If at time t is equals to 0, the displacement is x naught, then x is equals to x naught plus vt, or x minus x naught is equals to vt, or we can say that s is equals to vt. So now, non-uniform motion. A body is said to be in non-uniform motion if its velocity changes with time. Now, acceleration. The rate of change of velocity of an object is called its acceleration. Acceleration is equals to change in velocity upon time taken. It is also of four types: uniform, variable, average, and instantaneous. Uniform acceleration. If the velocity of an object changes by equal amounts in equal intervals of time, however small these intervals may be, then the object is said to be moved with uniform or constant acceleration. Variable acceleration. If the velocity of an object changes by unequal amounts in equal intervals of time, then the object is said to be in variable acceleration. Now, average acceleration. The average acceleration of an object between 2 points on the path of its motion is defined as a ratio of the change in velocity to the total time interval in which that change has taken place. Average acceleration will be equals to v2 minus v1 upon t2 minus t2, which can be written as del v upon del t. Now, last one is instantaneous acceleration. The acceleration of an object at a given instant of time or at a given point of its motion is called instantaneous acceleration, which is equals to dv upon dt, or we can say that dx square upon dt square. Now, positive acceleration. If the velocity of an object increases with time, its acceleration is positive. Negative acceleration. If the velocity of an object decreases with the time, its acceleration is negative. The negative acceleration is also called retardation or deceleration. Now, equation of motion for constant acceleration. A. In conventional form, let u be initial velocity of a particle. A is the uniform acceleration, and v is its velocity after time t, and s is the distance traveled in time t, then the following equations holds a good. First is v is equals to u plus at, and second is s is equals to v plus u, or u plus v by 2 into t. Third is s is equals to ut plus half at square. Fourth is v square minus u square is equals to 2as. S is equals to vt minus half at square. S nth is equals to u plus a by 2 into 2n minus 1. Where Sn is the distance traveled in nth second. And now in Cartesian form, suppose a particle moves with a uniform acceleration a along x-axis. Let x naught and x be its position coordinates, and v naught and v be its velocity at time t is equals to 0 and time t respectively. Then the following equation holds a good. V is equals to v naught plus at, and next is x is equals to x naught plus v naught t plus half at square, or s is equals to v naught t plus half at square. And next is v square is equals to v naught square plus 2a x minus x naught is equals to v naught square plus 2as. And last one is Snth is equals to v naught plus a by 2 2n minus 1. Now free fall. In the absence of air resistance, all bodies fall with the same acceleration near the surface of the earth. This motion of a body falling towards the earth from a small height is called free fall. The acceleration with which a body falls is called acceleration due to gravity, and it is denoted by small g. Near the surface of the earth, g is equals to 9.8 meter per second square. Now motion under gravity. For a freely falling body, the following equations of motion holds a good. First is v is equals to u plus gt. Second is s is equals to ut plus half gt square. Third is v square minus u square is equals to 2gs. When a body falls freely under the action of gravity, its velocity increases and the value of g is taken positive. When a body is thrown vertically upward, its velocity decreases and the value of g is taken negative. For a body thrown vertically upward with initial velocity u, we have this. First is maximum height reached, h is equals to u square upon 2g. And next is time of ascent is equals to time of descent, which is equals to u upon g. And third one is the total time of light to come back to the point of projection is equals to 2u upon g. And fourth one is velocity of fall at the point of projection, which is equals to u. And last one is the velocity attained by a body dropped through a height h. V is equals to under root 2gh. Okay, now position time graph. It is the graph between the time t and position x of a particle relative to a fixed origin. Its slope at any point gives the instantaneous velocity at that point. Now first thing, for a stationary object, the position time graph is a straight line parallel to the time axis. Second thing is that for a body in uniform motion, the position time graph is a straight line inclined to the time axis. And the third thing is that for a uniformly accelerated motion, the position time graph is a parabola. Now velocity time graph. It is a graph of time versus velocity. Its slope at any point gives the acceleration at the corresponding instant. Distance covered in time t equals area under the velocity time graph bounded by the time axis. First point is that for a uniform motion, the velocity time graph is a straight line parallel to the time axis. Second thing is that For a uniform acceleration, the velocity time graph is a straight line inclined to the time axis. And the third thing is that for a variable acceleration, the velocity time graph is a curve. Now, relative velocity. The relative velocity of an object B with respect to an object A when both are in motion is the rate of change of position of A of object B with respect to object A. Now, relative velocity of object B with respect to object A is this: VAB is equals to VA minus VB. Relative velocity of object A with respect to object B is this: VAB, this is BA. And now relative velocity of object A with respect to object B is equals to VAB is equals to VA minus, this is VB minus VA. Okay, and this is a VA minus VB. And now when both the objects A and B move in the same direction, VAB is equals to VA minus VB. When both object B moves in the opposite direction, then VAB is equals to VA plus VB. And now when, hope you can see this. Now when VA and VB are inclined to each other at angle theta, then VAB is equals to under root VA square plus VB square plus 2 VA VB cos 180 degree minus theta, which can be written as VA square plus VB square minus 2 VA VB cos theta. And if AB makes angle beta with VA, then tan beta is equals to VB sin theta upon VA minus VB cos theta. Thank you.